Hello everyone, my name is Adnane Guettaf. Thank you for listening to this presentation about our work titled Effect of Physical Challenging Activity on Tactile Texture Recognition for Mobile Surface. We will begin our presentation first with the motivation that inspired us to conduct this work. Interacting with touch devices allow user to directly manipulate digital elements through touch, and recently allows also to perceive touched objects through tactile feedback. Several approaches have been proposed to enhance haptic capabilities in touchscreen devices using mainly two technologies to provide the user with simulation when touching the surface. In one hand, we have electrovibration technologies which enhance the friction between the finger and the interaction surface, and the other hand, we have also ultrasonic technologies which reduce the friction through the squeeze film effect. Also, previous research on tactile texture recognition demonstrates the ability for users to accurately recognize texture even when using different finger speeds or when perceiving simultaneous but different texture or when the size of the tactile texture is small. Researchers have also proposed different applications to strengthen the interaction or to enhance the expressiveness of touched objects or to offer accessible interaction designed for people with impairment. However, all those studies were evaluated in a lab setting, where participants had to focus only on tactile feedback-based tasks, which limit the overall generalization of those findings for other more realistic scenarios, like for example, when standing, walking, or even being in a public transport where the user attention can be directed toward other tasks that require certain attention and visual load. Now we will explain the experiment section. We conduct an experiment to evaluate the effect of physical challenging activities on user perception of tactile textures. We considered here 5 challenging activities that we think represent common situations where users often use their smartphone, which are seated in the office, standing in the office, standing in the tramway, seated in the tramway, and finally walking the street. 12 participants volunteered to take part in our experiments. We used the Evita device for this experiment. Tactile feedback tablet that supports friction modulation by means of ultrasonic vibrations. We considered here 4 different tactile textures. We encode the different texture with respect to different texture densities from the densest one to the sparse texture and by alternating high and low friction. Here high friction is associated with black color as you can see and low friction with the white color. The set of considered texture was used in previous research and proved to be distinguishable by user. We now present the results. We present here the quantitative results for each of the dependent variable accuracy, recognition times, number of swipes, and number of clutch. For the accuracy, which is the proportion of correct identification of texture, we can notice that there is a significant main effect of activity. Post-hoc tests revealed that working in the street deteriorates significantly the performance compared to the remaining activities. For the recognition time, which is the presented time taken by a participant to sense and recognize the texture, we observed also a significant main effect of activity, with walking being significantly slower than both seated in the office and standing in the tramway. For the number of swipe, which is defined as the number of times the user moves his finger on the surface from left to right and from right to left, found that walking produces significantly more swipe gesture than standing in the tram, with no significant difference with the remainder activities. And finally, for the number of clutch, which is defined as the number of times the user released his finger from the surface and put it again on the surface, we found no significant difference between the 5 activities. Overall, we also observed that working in the street deteriorated the performance compared to the remainder condition by 8%. For the qualitative result, most participants felt that when working in the street, identifying the perceived texture is harder and more mentally challenging than when being in the remainder activities, which was correlated with users' response to the nasal TLX questionnaire and the participant remarks collected during the experiment. As we can see, that one participant clearly stated that it was more difficult for me to manage 2 tasks simultaneously, working and performing the experiment, or another participant that said, when working I had difficulties sometimes to differentiate between the 4 textures due to physical activity. In contrast, participants stated their satisfaction in recognizing the texture when being in the office or in the tramway condition. For the office condition, one participant said that when being in the office, I'm more sure about my touch sense and choices, and I can easily distinguish the different textures. And another stated here for the dynamic environment, as I use always my phone in the tramway, I feel confident about my response. To summarize our results, we found that both postures, here we had seated and standing, do not impact the performance in both static and dynamic environments. We found also that being in the dynamic environment do not necessarily impact recognition, as we do not found any effect on either accuracy or recognition times. Our result also showed that working in the street had an impact on recognition rate. We observed a decrease of performance up to 8.45%. However, while at first glance it may look like using tactile texture while working in the street is unusual, the recognition accuracy did achieve a good rate of 82.87%. Consequently, this suggests that tactile texture could be effectively recognized and used by users when working in the street. For our future work, we are considering the study of more challenging or different posture like lying down, for example. Also, our result cannot be generalized for other vehicle contexts which may have different traveling speed and can produce more or fewer jitters that are likely to be the reason why tactile recognition increase in difficulty. Also, for the street context, we consider here only the working activity, so the result remains uncertain for other activities like running or working at different speeds. Thank you everyone, and thank you for your attention.